Hey kids, we are starting section 5.5 today. Let's see if I can get my camera lined up nicely. A little bit. Okay, so we are talking about today using graphs and equations to represent those proportions we've been talking about. Remember, so when when two fractions equal each other, we say that they form a proportion. So if I were talking about, let's say, traveling at 60 miles an hour in a vehicle, and whether I travel an hour, 2 hours, 3 hours, and my rate is constant, the distance I travel is 60 miles each hour. And then we can plot those points and make a graph, and then also have an equation that goes along with that graph. So that's what we're doing today. It's new. That's okay. So just bear with me, and the more you practice, I think the better that this will get. So the learning target is I will be able to use graphs and equations to represent proportional relationships. So that's just a big fancy word for saying, hey, we have these two fractions and it's constant, and we know that they're equal to each other. So like I was talking about, whether I travel 60 miles in 1 hour or 180 in 3 hours, every hour have been traveling 60 miles per hour. Okay, so the fancy definition of all of this is saying that two quantities, x and y, are proportional. Then that's just meaning that their rate is the same every time when y equals a number k times x, where k is a number and k is not equal to 0. So the number k represents the multiplicative relationship between the quantities, and that is called, I had it just a minute. I think it's the constant proportionality. Let me make sure. Oh, it is called that. Okay, so it's called the constant of proportionality. And I know these words seem really big and what on earth is she talking about? But just bear with me, like I said. Okay, another term for this is called direct variation. So the relationship has direct variation. So this is another term. Big Ideas has changed it to constant of proportionality. The old book used to talk about direct variation. So anyway, here we go. So how do we determine by looking at graphs if what we're talking about has a constant of proportionality, like that the rate is the same? So if I'm talking about the cost of grapes at the store, for you, for me, for anyone, however much we buy, whether I buy 1 pound of grapes or 2 pounds of grapes, or you come in and buy half a pound of grape, we are all paying the same amount per pound. So that is a constant proportionality. But if I come in and buy a pound and I'm charged $5.25 for the pound of grapes, and then you come in and you're only charged $3.25, there is not a constant of proportionality. Something has changed, right? So there's been a price drop. And you're going to pay less. Even if you bought 5 pounds of grapes at that price, you're paying less than I did per pound. So that would not have a constant of proportionality. I know, big fancy word, right? For that the price changed. Okay, so how do we do this if we're looking at a graph here? So this is given. This is the table for part A. We're just looking at part A. So you would plot the points, see the X and the Y. So 1, -2 was plotted, 2, 0 was plotted, 3, 2, 4, 4. Okay, so we see all these points make a line. That's nice. But if they do not go through 0, 0, we can say that there's not a constant of proportionality. Okay, so this graph does not go through the origin, which is 0, 0. Okay, so That is called the origin of the graph. So this does not have constant of proportionality. Okay, X and Y are not proportional. So if we were to compare this point to another point and we set them up as fractions, right? X over Y, we're not going to have them equal to each other. So think about this. If I said 1/2, is that equal to 3/2? That's negative, right? No way, no how. Those two are not equal, right? This is 1 and 1/2. This is negative 1/2. That's not, no. So there's no proportionality, or there's not a constant of proportionality going on. They're not proportional. So let's look at this one, right? So this is what we used to do before. We used to look at these tables and look at them in terms of fractions and seeing if they formed a proportion. Well, we have a quick way to do it. If we graph the points and doesn't go through 0, 0, boom, they don't form a proportion. Okay, looking over here. Look at it, does go through the origin. This graph does. The graph does go through 0, 0. So yes, X and Y have a proportional relationship, or they have a constant of proportionality. I'm just finishing that up. Okay, so again, if we look at what we used to do, 2 to 2, right? Does that equal 4 to 4? Yeah, 1 equals 1, right? And even though 0 to 0 equals 0, technically, but it's a 1-to-1 ratio, right? It's a 1-to-1. It's the same. So this has proportion. This is proportional, okay? All right, so if we try these, you could try it on your own. You can pause the video and see if you could figure it out. But if we look right away, this one, boom, right away, we know this one goes through the origin because look, 0, 0. So yes, X and Y are proportional. Okay. This one goes through 0, -2. So this one's not going through the origin. If in order for it to go to the origin, this would have to be a 0. So this one's not going through the origin. And so X and Y are not proportional. Okay, now let's take a look at this one. This one's unique, and this is why. So if I just compare X and Y, what do you see is it being multiplied by? What's X being multiplied by? It's being multiplied by 4 every time. Every time it's being multiplied by 4, right? So if we go back up here, if we look at the definition, right, two quantities X and Y are proportional when Y equals Kx and K is a number. So if we look at this, right, this follows this. What's K? K happens to be 4 here, right? So 4 times 1 is 4. 4 times 2, and subbing in 2 for X, that's 8. Oh, okay, so we have found that K is representing that multiplicative relationship between the quantities, right? If we go back up to our definition. So we have found that it does have a constant of proportionality. 4 is the constant K. And if you were to graph all these points and connect the line or the dots, right, you would see it would go through 0, 0. All right, so then this one is a yes. X and Y are proportional. Okay? All right, so remember, pause is needed, go back, look again, think through, and hopefully that this makes sense. All right, so now, finding unit rate. So instead of writing all this, I've copied it for you. This comes directly from the book. So let's take a look at this graph. So the graph shows the speed of a subway car. So over time, right, this is the distance in miles. So at a half a minute, right, the subway car has gone a quarter of a mile. After 1 minute, it's gone half a mile. And if we look farther on the graph at 2 minutes, it's traveled 1 mile. Okay, so first things first is that the graph is going through 0, 0. So the time and the distance are proportional. Okay, so now your job is to find the speed in miles per minute. So there's two ways. You could just look at the point 2, 1, and that means it has traveled in 2 minutes. 2 minutes. It has traveled 1 mile. But we want miles per minute, right? We want miles per minute. So it travels 1 mile every 2 minutes, right? So in order to then simplify this, right, we just divide 1 by 2, which is half, right? So half a mile in 1 minute. Okay, that's not too bad. Easy peasy, right? So that's the unit rate. Remember, we talked about before that unit rate is per one. All right, and then it says it right here. So it's half a mile per minute. That's the speed of the subway car. The other way to look at this is look at 1 and 1/2 as the point, right, to find the speed. So here, right here, after 1 minute, the car has traveled, or the subway car has traveled half a mile. So half a mile every 1 minute. It's the same thing as we figured out from above. So remember, when something is proportional, when you simplify either of the fractions that you're comparing and they equal each other, then that means they're proportional, right? So here's the thing. Does our answer change if we look at the point 1/2 minute it travels a quarter? Okay, right? So this data point here is on that line. So this fraction or this proportion should be the same, right? Because it's, even though it's not as much time has passed, it's still traveling at the same speed. It should be. So let's try to figure this out. So half a minute, and it travels a quarter mile in that time, right? So we want miles per minute. So we're just going to flip this. So it travels a quarter mile in half a minute. All right, so what do we know about ratios? Well, really, they're just a division problem. So this is really 1/4 divided by 1/2. So I do 1/4 divided by 1/2. Okay, right? That's what that means. Remember from last time? So we just changed this here. Okay, so 1/4 times 2/1. Because of the division of fractions, we have to keep, change, flip, right? I'm just going to put a little arrow so we remember. So it's keep, change, flip. So then this is 2/4, which that simplifies to 1/2. 1/2 miles per minute. Because when I divide the top by the bottom, every time it makes it into my unit rate, it's just over 1. Because any number I get, I can just write it over 1. Look, it's the same. So every time, any data point on the line, right, any set, any x, y, when we compare it, they should be every time when we simplify it the same fraction, and they are. Okay, so it doesn't change our unit rate even though we looked at a different point. Okay, so still same rate. That's how we know it's proportional. There's proportionality there. All right, so last sheet in your notes packet here. Let's take a look at this. We're going to do this one together. You guys are going to have a problem similar to this. Okay, so the table shows the temperature Y in degrees Fahrenheit, X hours after midnight. Okay, so at midnight, what's the temperature? 42 degrees. So what do we see as the night progresses into the wee hours of the morning? Temperature is increasing. Okay, that's always good. All right, so describe the proportional relationship between time and temperature shown by the table. Well, one thing we know is this does not have a direct variation, or there's not a proportional constant, but that's okay. That doesn't mean there still isn't a relationship of some kind after midnight. Okay, so we still want to describe what's happening after midnight. So what do we notice? Temperature is increasing how much? 2 degrees every what? Every half hour. So +2, +2, +2, and then here it's every 30 minutes, right? Or we would say every half hour, right? I actually should go 0.5 hours plus 0.5 hours. Okay. All right, so we know that the temperature, Y, started at 42 degrees, right, after no hours, plus it's increasing 2 degrees times every half hour, right, times the change, right, every half hour. It's changing 2 degrees. We're letting X be the hours, so that's why I didn't put 0.5 here. Does that make sense so far? Because if it was no hours, temperature is 40 degrees. But once I have half an hour in there, it bumps up 2. What do you think? I'm thinking that's only going to change it by 1. So we want to actually change this to 4, right? Because half of 4 is 2. And then from here to here, it changed by 4. So if we change it by times 1, then that would be 4. All right, so put in 3.5 hours. 3.5 hours. So Y equals 42 plus 4 times 3.5. Y equals 42 plus, what is this? 14, right? So my total temperature after 3.5 hours after midnight should be at 56 degrees Fahrenheit. So you could increase the table here and just see, right? Test it. So if we have 2 hours, and then this is 2.5, and then this is 3, and then this is 3.5. So if this is changing 2, this should be 50, 52, 54, 56. All right, so what we've done is we've we have determined that there is an equation, right? Because we talked about tables representing proportions. We talked about the line graphs representing proportion. And so now here we have this equation that can determine this outcome after midnight. right? The change in temperature here. So plugging in what we know and using X 3.5 hours after midnight, we get that 56 degrees. 56 degrees. And then we also tested it just by expanding the table. All right, so new stuff here we're talking about. Give it a go, give it a try. I'm going to give you quizzes to do some warm-up practice with this, and then I'll give you the big ideas to work on to finish up your practice with looking at this new concept of constant of proportionality. Okay, so you guys have today, Thursday, and tomorrow, Friday, to finish up. When you finished everything, make sure you're working on your extra credit, the Elmo. If you have any questions, please email me. Sorry, the notes on this were a little long, but again, you have 2 days to do the practice. All right, take care.